Welcome students. Chapter number 1, Rotational Dynamics, Part 2. Conical Pendulum. A tiny mass connected to a long feasible massless intensible string and suspended to a rigid support is called conical pendulum. If a string is made to oscillate in a single vertical plane, it is simple pendulum. The string moves along a surface of right circular cone of vertical axis and the point object performs a uniform horizontal circular motion. The system is called conical pendulum. Equation of conical pendulum. Consider a conical pendulum having bob of mass m and string of length L. In position B, the force acting on bob are two forces are there, its weight and second is its tension. Now, a motion of bob is horizontal circular motion. The resultant force must be horizontal and directed towards the center of C of a circular motion. Two forces are there. One is this force, that is the tension, and second is its weight. That for tension is divided into two components. Now T0 is resolved into two components, T cos theta and T sin theta. And T cos theta balances the weight mg and T sin theta becomes the centripetal force. So you will get the equation for T sin theta, that is the mr omega square, and T cos theta, that is the mg. This is equation number 1 and 2. Dividing equation number 1 and 2, we will get sin theta upon cos theta. T0 will be cancelled here and is equal to r omega square upon g. Here m also cancelled here and T0 is cancelled. And next equation we will get omega square is equal to g r sin theta upon r cos theta. That is, radius of circular motion is small r equal to L sin theta. If t is the period of revolutions of the bob, then we can write the equation for omega, that is 2 pi upon t is equal to root of g L cos theta. Means we are putting the value of r here, that is L sin theta. So you will get the here equation root of g upon L cos theta. Sin theta will be cancelled and cos theta will be there. So equation is there. So period, that is t equal to 2 pi root of opposite is there because t is an denominator. So 2 pi root of L cos theta upon g. So frequency n equal to 1 upon t is equal to 1 upon 2 pi root of g upon L cos theta. Vertical circular motion means the speed is constant or not totally controlled by gravity and controlled by gravity. So one equation from that topic is case first mass tied to a string. Consider a bob tied to a massless, intensible and flexible string. It is reeled along a vertical circle. So the bob performs vertical circular motion and the string rotates in a vertical plane. Now here also on that bob, two forces are there. One is its weight and second is its tension. Now here you will get the three position, that is the upper position, lower position and middle position. And we are getting three equations for upper position, lower position and middle position. At upper position here you will get the two equations mg and ta, two forces are there and that two forces are centripetal, equal to centripetal forces. So mg plus ta equal to mva square upon r. For minimum speed, we can say that TA is 0, that is it slacks because the string becomes slack. So it becomes slack, so the tension will be 0 here. So you will get the equation T0, TA is 0, so equation is mg plus mv square upon r. So we will get the minimum speed, that is root of rg. Lower position. Force due to the tension TB is vertically upward, so that is opposite to mg. So here also the resultant is centripetal force, means here tension and mg both are in opposite directions. If vb is the speed of lowest point, then you will get the equation for tb, that is tb minus mg is equal to mvb square upon r. negative sign because both are in opposite directions. And an object moves from A to B, there is a decrease in potential energy and increase in kinetic energy. So means it is going from upper side to lower side. So total kinetic energy at one side to total kinetic energy at B side, both are equal here. So we have say kinetic energy, potential energy, addition of both. So 1 half mv square plus mgha is equal to 1 half mvb square plus mghb. Both are equal here, and you will get the equation. Here va is the root of rg, ha is 2r, and hb is 0. So you will get, putting this equation in this equation, you will get the equation for VB, that is 5 root of 5 Rg, that is the lowest position. Then substituting equation 1 and 2, you will get the Ta minus Tb, that is minus 2mg is equal to 1 up m upon R into Vb square minus Va square. Put in the value of Va in this equation. You will get the equation 6mg. This equation is very important. Now position when the string is horizontal means at middle position, you will get here also energy is not created nor destroyed. It can convert from other form, a one form to other form. We know the law of conservation of energy, and because of that law we can say that total energy at B is equal to total energy at C. Means total kinetic energy per potential energy at B point is equal to kinetic energy per potential energy at C point. Both are equal here, and putting the value of both equations here, you will get 1 half mvb square plus mghb plus is equal to 1 half mvc square plus mgsc. Now here also we are putting the value of vb, that is root of gr, and hb is equal to 0, sc is equal to 0. You will get here, now here vb is equal to 5gr, not gr. So 5gr plus 0 is equal to 1 half mvc square plus mgr. So you will get the point, you will get the speed for VC, that is equal to root of 3gr. Means at upper side you will get the equation for V, that is equal to root Rg. At middle point you will get the equation root of 3Rg, and at lowest point you will get the equation that is root 5Rg. These are the three equations. Now, moment of inertia of an analogous quantity for mass. Here, you have to take a rigid body and n numbers of particle is there, and masses is m1, m2, m3, and radius perpendicular distance from the center, that is r1, r2, r3, and speed is v1, v2, v3. So, kinetic energy is equal to 1 half m1 v1 square, 1 half m2 v2 square. And when you will take the total kinetic energy, that is 1 half m1 r1 square omega square, both are, we are adding n numbers of particles, you will get the equation, that is. Now moment of inertia of a uniform ring, that equation is mr square. Moment of inertia of a uniform disk, this equation also very important. You know, last year we have seen mass per unit area of the disk, that is sigma equal to mass upon area, that is m upon pi r square. Now here area of that disk, that is 2 pi r dr. Okay. So sigma is equal to dm upon 2 pi r dr. So dm equal to 2 pi r dr sigma. You will get the equation for moment of inertia of a disk, that is 1 half m r square. How you will get, because moment of inertia of disk can now obtained by integrating at IR. And what is the IR? IR, that is dm into r square. So integrating IR where limit is 0 to r, you will get the equation for moment of inertia of a uniform disk, that is 1 half m r square. Radius of gyration, that is k equal to root of I upon m. This is the radius of gyration. Last year we have seen. Now theorem of parallel axis. It means here moment of inertia of an object about any axis is the sum of moment of inertia about the axis parallel to the given axis and passing through the center of mass, and the product of mass and the square of distance between them. Here MOX and ACB are the two axes here, and you will get the H is equal to CO, that is the perpendicular distance between two axes. Then here you have taken the small element, that is the DM, it is located at point P, and here the perpendicular distance is there from D point, that is the N. you will get the equation that is IC, moment of inertia of an object about ACB, that is equal to dc square dm. Means I0 is equal to d0 square. I0, that is the d0, and d0 means what? Dn on square plus dn square. So we have taken the Pythagoras theorem, and we can put the value of OC plus Cn here, and solving that bracket, you will get the last equation, that is integration of dc square dm plus 2h into integration of nc dm plus s square integration of dm. Now here IC, that is equal to integration of dc square dm and integration of dm, that is capital M. So by definition of center of mass, the integration of nc dm is equal to 0, and you will get the equation for I0 equal to IC plus ms square. Same equation is there for, this is the parallel axis and perpendicular equation also. So theorem for parallel axis and theorem for perpendicular axis, both are important here. Okay, and one equation also there for torque, that equation also same here in this equation. Okay, thank you.